Here's number 48 from section 4.3. In this exercise, we want to use the graph of f prime to estimate the intervals on which a, the function is increasing, b is decreasing, and then also part C, estimate the x-coordinate of all local extreme values. We want to assume that the function f is continuous. That's important, even at the points where f prime is undefined. So notice that in this graph of f prime, we do have a domain that is not completely continuous. We are continuous from 0 to 1, from 1 to 2, and from 2 to 3, so says the direction. So keep that in mind, but also that f itself is continuous. So the graph of f is going to be able to be completed with one pencil stroke. So let's start talking about question A. We want to find where f is increasing. We know that f is increasing. I'll write this here. F is increasing when f prime is positive. Well, where's f prime positive? Looks to me like everywhere. F prime is positive all along here, all along this second piece, all along the third piece. In fact, f prime never goes below the x-axis. So our answer here, we want to say that f is increasing on the entire interval 0 to 3, because f prime is always positive. Well, that makes part B pretty easy. Where is f decreasing? Well, nowhere, because there's never any point where f prime is negative. So we'll finish that up. And finally, part C, estimate the x-coordinates of any local extreme values. Well, there are no local minimums or maximums inside 0 to 3 because we never have any point where f changes from increasing to decreasing or decreasing to increase. That doesn't happen in 0 to 3. So that leaves just the endpoints. So when x is equal to 0 or at x equals 0, the left side of the endpoint, x equals 0, f prime is positive on the other side, f prime positive here. So that means at 0 we start to increase, which means locally x equals 0 is a minimum. So local min at x equals 0. On the other side of the graph, at x equals 3, we have the right endpoint. X equals 3, that's our right endpoint. Just to the left of that endpoint, the function is increasing as well. We have f prime positive once more, and that means the graph is increasing. So if we increase to our right endpoint, that makes the right endpoint a local max. So we have a local max at x equals 3. But again, no local minimums or maximums at all between 0 and 3 because we never have any point where the derivative changes sign. And that takes care of 48.